This is going on page 52 when we're done. So we're going to look at polynomials, which ties to the sketching of the polynomial. As we go through this, I'll tell you about a couple of applications that you will see for this. So there's all these steps right now, but we'll go through them. It's not nearly, but the steps right now. So write the polynomial standard form. So that means when a form where the right-hand side is 0. So that's already done for us. Right-hand side, so that's nice. This thing can be greater than, less than, greater than, equal to, like any of the four work. And then we're supposed to find all the real zeros of the polynomial. Let's go ahead and just do that. So since it's factored for me, that's nice. What would my smallest one be? -4, and then 1, and my real zeros. And there's my inequality. Now, the inequality, the fact that it's asking me for something that is less than 0, here saying is of x, looking for when it's negative. Okay. Our zeros find when it's, what we're going to look for when it is 0. So it says to plot the real zeros on a number line, dividing the number line into intervals. So that's why there's a space down here. So we're going to draw a line, like a number line. You can use number lines for many things. And plot the real zeros. So we don't have to put 1,000 little hash marks on there. If this is -4 here, then that could be like 1 right there and 3, right? Like 1 and 3 are close. The point. And just like in then my circle, what? Open. So I have open circles here at those zeros, right? Here. The test number, right? I'm going to rewrite that polynomial because when I scroll, you can't see it. You don't necessarily have to rewrite yours because you can see yours. But this is x minus 3 times x minus 1 times x plus 4, which is less than 0. And I did copy that down, right? Yes? Okay, good deal. The directions say that we are going to choose a test number that is easy to compute with in each interval. Substitute the number in each factor and determine the resulting sign. Does it say just determine the resulting value? No, I don't care about the values. It says determine the resulting sign. So all I care about is the positive or negative. I don't care. Then we construct a sign chart, and that's what we're doing right now before we get to step 5. So this is intervals, right? We should understand how number lines work and inequalities and stuff. So if we're over negative, but I also don't care about the big part of it. All I care about is the one this substituted in here. Then when I substitute -5 in here, would this term be positive or negative? Negative. Okay. So the number you get is going to be positive or negative? Negative. Okay. So in this section of it, I can substitute in 0. 0, that would give me a negative. 0 in there would give me negative. 0 in here would give me a positive. So when I multiply all those out, what do I get? So then I'd pick 2, and 2 here would give me negative. 2 in here would be positive. And 2 in here would give me positive. So when I multiply all those out, I get negative 4. Then something bigger than 3. 4 minus 3 would be positive, and then positive, positive. Now, these alternate, always alternate, because if we did, the one that we think I just did. Then my step 5, considered your sign from my chart. We're going to shape the parts of the number line 0, which means do I want the positive or the negative? I shade the negative, I shade the negative, and part of my answer is my number line. The other part is that I have to actually write the intervals out. So from negative infinity to negative 4, do I include the negative 4? No, that's an open circle. And then again from 1 to 3. So that is the interval where the function is less than 0, or it's negative. So when you get into calculus, you're going to talk a lot about this little particle that's on the x-axis, and this particle moves left and right on the x-axis, just back and forth, okay? And you find things out about it, right? Velocity, acceleration, all that kind of stuff, direction. So if you're looking at a velocity graph of what this particle is doing, when your velocity graph is positive, it's moving to the right. When your velocity graph is negative, it's moving to the left. That's something that they were doing in Calculus AB a couple weeks ago, actually using this exact same thing here to figure out what was happening with the particle. We are going to use this, because we're not going to look at the particle, but we're going to use this when we graph rationals, because I know y'all have done rationals before. We're doing rationals again, but we're not doing them the exact same way, or what would be the point. But we're going to need the sign chart to help us with some of the more complex graphs. But sign charts in themselves, not that bad, right? We good? Yes? All right, so let's look at this first example. It says, show the solution of each polynomial inequality on a number line and an interval notation. I need my zeros. Since it's already all factored for me, that's nice. It's my smallest one. Negative 3, then 0, then 1. My number. So I can make that negative 3, 0, and 1. A little bit closer together. Are my close? I'll know how to figure that out, right? Then my sign chart. So and then negative 1, which would be negative, negative, positive. That becomes positive. In here, I'm going to have to choose a fraction, but don't actually. So 1/2, right? So that's going to be positive, and then 1/2 minus 1 would be negative, and then positive. So overall, that's negative. Positive, positive, positive. But again, that does not happen every single time. I've got to shade, and this time I want it to be greater than or equal to 0, so I'm shading the positive, which means I'm going from negative 3 to 0. Do I include negative 3? Yes. Do I include 0? Yes. And then I start back over at 1 and go to infinity. Any questions at all? We good? Yes. All right, awesome. So let's look at number 2. All right, so my x, or my zeros, is going to be negative 2 and 3, right? Okay, figuring that out. Number line, and 3 are my points open or go to construct my sign chart. There is not an x right here, but that number here, some number here that has some sign on it, but then those things are going to be multiplied by that -1. So this sign matters, right? When I substitute in like a -3, you get negative. And then what would I get here? Negative or positive? When I substitute in a -3? Negative, because -3 minus 3 would still be negative. What about when I substitute in a -3 here? Yes, I'm going to square it. Is there any way? Negative, negative, positive. Positive. All right, see if you can finish out this sign chart. You agree with this? Yes. And each situation, you're going to see the negative and it ends with a positive. So the one that really matters is this one right here. You have to figure out so you can multiply them. Okay? We good with that? We understand how this chart works? Now I got to shape it, right? It's got to be greater than 0. So what am I shading? Positive. I shade this and this. So when I go to write my interval, am I going from -infinity to 3? No. I go from -infinity to what? -2. Do I include the -2? No. Because then I start back over at -2 to 3. Do I include 3? No. Okay, and that's it. Now, I want you to think about something. This number line is, yeah, it's just a number line, but we could look at it as the x-axis. When we were sketching polynomials, we had to find the zeros, which we've already found and plotted on here, sort of. We had to find the y-intercept, which we're not going to worry about right now, and the end behavior, right? So this is what's the degree of polynomial? 3, right? And so what is the end behavior going to look like? Down, up, or up, down? Up, down. So my end behavior looks like this, which means that left part of my graph before it ever hits the x-axis is going to have to be positive, right? And look what's happening here. And the far right part of my graph is going to have to be negative because we're going to -infinity. What's happening in here at this -2? It's a bounce, and I want you to think that way. It's tangent to the axis there. That number line. Polynomial, because I know that it's positive, so coming down from infinity, it's going to bounce right here and come back up and then come down this way. This has to be a bounce because I'm on the x-axis, but it's positive on either side of it, so there's no way it crosses through, and that's basically a sketch of your polynomial. Make sense? So it's the same thing. You can sketch that in on your notes because I want a couple of them. You don't have to sketch it on your assignment on every single one of them, but I just want you to see how they're all kind of connected together. Okay, we good? Because if I get the graph, well, you wouldn't need a chart, right? Because you can see where it's negative and positive. All right, everybody good? Any questions? All right, let's look at number 3. So number 3, my zeros are going to be -4, 1, and 2. Yes? Okay. And then there's this. So -4 can be down here, and then 1 and 2 are going to be closer to each other. Are my circles opened or closed? Closed circles. All right, I'm going to let you work on this sign chart here. that what you got? Did you have a question? Do you mind asking me your question? You're probably not the only one that's wondering that. Do you mind asking me what you, tell me what you asked him? I'm fine that.
He just pointed it out that he has to do it.
Okay, all right, good. I will say whatever it is, I'm sure you weren't the only one. Yeah. Don't forget this very first negative because that is important, right? This is important. This is basic. This has an exponent of 3. The sign doesn't change, right? This is squared positive no matter what. Every single time you're going to start with a negative and end with a positive. And these two are the only two that you have to figure out every time. Does that make sense to you? We all good with that? Any questions? Yes. This part, when you multiply them together, a negative times a negative is a positive times a negative is a negative. And I got a shade, right? So I'm going to shade, and I want it to be negative, so I'm shading this part and this part, which means I'm going from negative infinity to negative 4. Do I include negative 4? Yes. And then I'm going from 2 to infinity. Any questions about that? Let's talk about the graph. Okay, so what's the degree of this polynomial? 6, right? So it's even and it's negative, which means my end behavior is down, down. And then what's happening here when this is right? And then this right here is what's happening here. It's your balance, which means this tangent, right? Terms, it's fine to think that way, but we make sure we do real words too. All right, so I know I'm having to come up from negative infinity, and that's negative. That's good. See if you can get this drawn in. Draw it without me, and then I'll draw mine in. Okay, like that? Maybe better. And again, we have no idea what the actual maximum values are, so it could go up a whole lot higher, but this is just a sketch in here. Could I, without even thinking, because I did the sign chart? Like, this is my behavior, but see how this is negative? I have to start. No, it's positive, and it stays positive. It has to bounce, and then it's negative. I end up that in behavior, even having to think that at the beginning, okay, because of the. Number 4. Let's look at what's happening on here. Now, number 4 is a little bit different. What's a little bit different about 4? It's not factored all the way, right? So we fix this a little bit. So I'm going to rewriting this. I've got negative times this x minus 1, and I want x to be first. So this changes to negative x plus 3. And then this right here, I'm going to try to factor it. Okay, and that's going to be greater than or equal to 0. So this is x to the 4. I can try to just treat it like a quadratic and make these both x squared. This sign is negative, so these are opposite. And the negative one would have to be bigger. What are my two numbers? 4 and 1. Okay, and which one's positive? 1. Okay, so 1 and 4, or 4 and 1, depending on what the word is. Can I factor this some more? Yes. Okay, so again, I'm going to start rewriting. This is negative times x minus 1. Now, I really want this to be, I need my x's. What do I do to make this positive? Factor out a negative 1. When I factor out that negative 1 and I bring it to the front and multiply, what happens to this? It becomes positive. And this becomes x what? Minus 3. And then can I factor this anymore? No. Can I factor this anymore? Yes, that would be x plus 2, x 2. And now I have it as factored as I can get it. Okay. So I need my zeros. My smallest 0 would be what? Get from here, negative 2. So negative 2, I'm also going to have this one, so I can go ahead and just put plus or minus 2. And then a 1, and a 3. Do I get any zeros out of this? What happened? Square roots are okay. What would be the square root of? -1. That's my problem, right? Okay, because this x squared plus 1, if I set it equal to 0, that would give me x squared equals -1. So x equals plus or minus the square root of -1, right? Which would be your I and imaginary numbers and whatnot. And is that something I can go plot on my axis? No. So look back at the front of this real quick. On step 2, it says find all real zeros. It does not just say find all zeros. It says find all zeros. Try and get as much as we can, but if you just can't because it's imaginary, then you can't. All right, so I only have 4 that I'm going to graph on my number line. So I have a -2, and then 1, 2, and 3. And when I plot my points, are they open circles or closed circles? Closed. All right, and then I'm going to, instead of doing my signs like horizontally, because this is cramped there, I'm going to do them vertically, just because it'll make it better. So I don't have to worry about this sign anymore because it's positive, right? If I substitute in a -3, -3 minus 1 will give me a negative number. Substitute it in here, I'm going to get a negative number. When I substitute -3 in here, what am I going to get? A positive number. Is there anything I can substitute into here that would give me a negative number out of it? No. Whatever I put in, I'm squaring it, right? Which means it's going to be positive, and then it's only going to be more positive. So this is going to be positive no matter what. And then my -3 in here would be negative. So in the end, what is this here? Positive. Okay. So then in here, I would pick 0 for me. So I substitute in my 0, it's going to give me negative. This is always positive. Positive. Means this is negative. Here, I'm going to have to pick a fraction again. This, my little hint to you, is the right one. I spent forever on this. I knew what it was supposed to come out like, but I was trying to fix and change things, so I wanted certain things to happen. I knew what was supposed to happen. That's how I made a problem. The wrong thing, and I was like, this is not supposed to be the answer. I was using 1/2, and 1/2 makes no sense, right? 1/2. Once I finally used the right number, then it worked. So I was like, why is this not working? So it's 1.5, 1.5. When you substitute that in there, it's positive, and then negative. This is always positive, and then obviously that's going to be positive, and then that 1.5 make that. So that makes that positive. Between 2 and 3 would be like 2.5, which means it would be positive, and then negative, and then positive. This will be positive and positive. So that's negative there. Then 4 would give me positive, 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 positive. And I want this to be greater, which means I want it to be negative. So shade those parts. Remember, the number answer to. So you're answering with the number line, and then you also write the intervals. This is going to go from -infinity to -2. Oops, do I include the -2? Yes, I did. Then I start back over at 1 to 2, and then I go from 3 to infinity. Okay. Any questions? All right, I want you to get this one drawn in while I pass out the homework. I can tell by my signs that I do not have an tangent anywhere, right? Because if I did, then I'd have lines that were the same next to each other. I don't have any points of inflection, so this is positive. So I've come down from positive infinity. That's negative, and then negative, and then positive again. And I got my worrying about the degree of the polynomial behavior looks like. The degree is what? 6? Okay, so it's positive, so this is my end behavior, but my sign chart kind of told me that too. Let me have to worry about it. You got it either way. Now, you do not have to draw in the graph all the ones on the assignment. You can if you want to, but you might be doing sign charts for things that are not polynomials, right? And so there's no need to draw it in. I just want you to see how it works. On the assignment, the lines that are there, I put those there for you to use as a number line. There should be plenty of room. I had plenty of room when I worked this. Even if you have to factor them, there's plenty of room for you to write your answer and write your stuff out, but I would just use the line that's there as your number line. Okay? Are we good? Any questions?